demand functions when the producers are operating in the factor market, and we solve this numerical as well. So anyone having any questions on this part? All right. So if there are no other questions, so with this last question that we did yesterday, we conclude our discussion on producers and cost. And from today, we are going to start our discussion on markets.
So,
Yes.
may I add something?
Sorry, Abhishek, you had what?
May I add something?
Yes, yeah.
So, like we haven't discussed a important topic like technological progress. So it is like you have
Technological
interest. Yeah,
technological progress
in production only.
in production.
Yeah, like using some technology, we can like we can produce the same level of amount output by using less labor. Or,
Abhishek, do you remember how we represent the Cobb-Douglas production function?
yeah, yeah, by using a that is representing the technology, but like the
Yeah,
derivation. Yeah, I was just talking about the derivation. Like we haven't discussed it, so
derivation of what? I can't follow you there. Derivation of what?
like if if there is a growth in Q, like output, then what will be the changes in L and K? Like I was talking about this.
If there is a change in Q, what will be the growth in L and K?
Yeah, like uh,
What?
so I think
I think you're getting
uh,
it confused with some solo concept.
no,
Growth in
so
L and Q?
not growth in L and Q, growth in Q, like by using less amount of labor because the technology has progressed. Like we are using the cap some machines or some technology which are in a practical way. If we are using the machines which by which we are able to reduce the labor force, so uh, and then the efficiency of production has been increased. Thereby we have now producing more with using less resources.
You want a derivation for this?
So there is a derivation in variant. So I was just referring that because I have a little bit doubt on him that thereby.
Uh, Abhishek, I can discuss that. That is not an issue. But the one that you're talking about, see, you have to. The idea over here is that we are preparing for our entrance exams, right? So I
Yeah,
will
yeah.
not be deriving everything because all the derivations and all that are there for the result are typically not important. The important part that you need to understand is how are we understanding the results, how are we going to mathematically represent them, and how are we going to use them to solve them. Okay.
So I'm asking is this because of like I was going through when PYQs, I found a question with the, like same to that concept. That's why I'm
I,
asking about it.
I get it, Abhishek. But that is something like if you're talking of technological progress, like derivation of that means you're basically asking what will be the change in output due to change in technological progress, right?
Yeah, yeah, yeah,
Correct. So dq by da, that's it for a given level L and K. So that will be simply L2 if you're taking a Cobb Douglas production function, वो A रह जाएगा और L to the power alpha K to the power beta रह जाएगा. So as the technology grows, the output grows in the same proportion. Bas.
yes. I
The
think
idea
this is
is
not
that, but yeah,
which I'm referring
technological
that is not very much
no, no, it's
as
fine. It's
simple as
fine. No, it's fine. It's fine. But like typically the derivation that you're talking about, or I would say the complete proof of that in a mathematical sense, that I will discuss in this context of solo model when I teach, because that is more relevant there. Okay. Separately, talking about the derivation of technology is not important, at least in cost and
Okay.
production. Okay.
Okay.
That's
Okay.
why we'll not be doing the derivation. All
Okay.
right. Yeah. So now let's come to the discussion on markets. So now, coming to markets, can any of you tell me what are the type of markets that you have encountered, the different kind of markets that you have encountered while you were studying economics?
Perfect competition, monopoly, oligopoly, and in oligopoly there Bertrand and Cournot.
Yes, Bertrand and Cournot are parts, perfect competition. This is one. Second one is monopoly. Third one is oligopoly. And any other that anyone might have come across? Any other name?
Monopolistic.
Monopolistic competition. Yes, this is one. Okay. These four essentially, these are the most four common, and obviously everything will have its subdivisions as we go along. So these are basically features of the product market, right? Where the goods are getting sold. Today, we will not be taking up any of these in particular one by one, but I want to focus on some broad concepts that will be needed in all of them, and some concepts that you might not have encountered them before in this way. All right. So, in general, if I talk about market, it basically has two sides, right? One is the demand side, and another is the supply side. And just to make our discussion clear, I am talking about the product market or goods market, not the factor market. Labor to capital wala market nahi. The demand side is constituted through the consumers who decide based on utility maximization. The supply side is based on producers who decide how much they want to produce and sell based on the profit maximization idea. Correct? Demand side graphically generates what we call it as the demand curve, and supply side generates what we call it as the supply curve. Correct? If I say, suppose that the market demand curve is given by QD, let's say I take a setup alpha minus beta P, where alpha and beta are positive. What does this mean? If I want to interpret, given a price level, what is the maximum quantity that the consumers are willing to buy? Correct? All of you agree with this? Any doubts on this? Because if I just try to plot this equation, how will it look like? If I simply take it in the standard way, I take Q on the horizontal axis, P on the vertical axis, then this will be a downward sloping demand curve. So this is your D basically. Correct. So if I say that if the consumers are wanting to consume a total of Q1 level of output, they are wanting to pay at max P1. But we must understand that if the same level of output Q1 is available at a lower price, then they will definitely buy it, right? That is not a problem. So that is why it becomes the maximum willingness to pay. That concept comes from here. All right. In a similar way, when we are talking of the market supply curve, usually we will be writing it in this way. Qs is equals to minus gamma plus delta P, where gamma and delta are two constants, which is positive. Correct? Again, if I draw it in a similar graph, it will be looking something like this. Q over here, P over here. The supply curve will be looking something like this. Correct? And here the interpretation will be that let's say the firms together want to produce output level of Q1. What is the minimum price at which they will sell? That is given by P1. Okay. For demand, it becomes the maximum price that they will accept. And from you take a look from the supply point of view, it is the minimum price at which they will produce the level of output. So the interpretation for this will be given a price level, what is the output level that all the firms together are willing to produce. Okay. Any questions on this? Any doubts? When we have defined the market demand and market supply, the next important concept that comes in is finding out the market equilibrium, right? And does anybody remember how we find it out given the demand and the supply curves?
Where they intersect.
Yes. So graphically, it's basically the point of demand supply intersection. So finding the market equilibrium is basically using the condition that quantity demanded should be equals to quantity supplied. Correct. This is what should hold. And graphically, we have the standard figure, just drawing it out once more for completeness. So this is my market. Given the structure, we have the negatively sloped demand curve and the positively sloped supply curve. The point where they meet is defined as the equilibrium, and the optimal level of quantity is usually denoted by capital Q star, and the optimal price level is denoted by capital P star. And writing out the equations once more, the demand equation is QD is equals to alpha minus beta P, where alpha and beta both are positive, and the supply equation is QS is equals to minus gamma plus delta P when gamma and delta are positive. Can all of you quickly calculate the values of P star and Q star? Can all of you quickly do that and tell me what are you getting? Given these equations.
Sir, will it be P equals to alpha minus gamma upon beta plus delta?
Alpha minus gamma. No, something is missing over there. You're talking about P, right?
Yes, sir.
No, recheck the calculation. Anyone else with any other answer?
Sir, P equal to alpha plus rho divided by beta plus delta,
Rho,
and rho means what is this?
gamma.
Gamma, sir. No.
You're
Alpha
talking
plus
about
gamma
P,
divided by,
right?
yes, sir.
P or Q? Which one?
P, sir.
P. It is what?
Alpha plus gamma divided by beta plus delta, and equal to gamma into alpha minus beta divided by beta plus delta
Alpha minus beta
into
by beta into
rho, alpha minus beta into rho
alpha minus beta into rho
divided by beta
divided
plus
by.
delta. Beta plus delta.
Is it?
Yes, sir.
Mm. P star is correct. So if you are substituting the P star in the demand equation, you will get the optimal Q star, which is alpha minus beta into alpha plus gamma by beta plus
Yeah, yeah.
delta. So this will be alpha times beta plus delta minus beta times alpha plus gamma divided by beta plus delta. So alpha beta plus alpha delta minus alpha beta minus beta gamma divided by beta plus delta. So alpha beta will get cancelled out and you're left with this alpha delta minus beta gamma.
Yeah, yeah. Correct.
Yeah.
Yeah, yes, sir. Not this is delta.
Uh-huh. Okay, just correct, just check the calculation, all of you. Whether you put the optimal P star in the supply curve or the demand curve, the answer shouldn't vary. Okay. So the equilibrium point is basically alpha delta minus beta gamma divided by beta plus delta. All right. All of you getting it? Anyone getting any other answers? Now there is something important that I want all of you to just observe and understand. When we are finding out the equilibrium, we are mathematically solving two equations, right? जैसे simultaneous equation solve करते थे वैसे just करके answer निकाल दिया. But when you look at the expression for P star and Q star, in order for them to be economically meaningful, there are two more things that we need to ensure. Number one, let me write it down in detail over here so that you all can understand. To ensure economic feasibility of the equilibrium, we need to ensure point number one, P star and Q star both should be positive values, right? Correct? Otherwise, they cannot be implemented. So now, if you look at the expressions that are there, the answer for P star that you have got is alpha plus gamma by beta plus delta, correct? And if you look at the equation structure, I have categorically mentioned that alpha and beta both are positive numbers, alpha, gamma and delta both are positive numbers. So with this, so this will be positive, and If you look at the expression for Q star, it is alpha delta minus beta gamma by beta plus delta. So over here, alpha and delta both are positive, so that makes this a positive number. Beta and delta are positives, and that makes it a positive number. But does it ensure that the numerator will be positive? Can anyone tell me?
No, sir.
No, exactly. That means you need to ensure, so this will be greater than 0. If and only if alpha delta is greater than beta gamma.
Yeah.
Okay. This is very important because सिर्फ आपको equation solve नहीं करना है. It is not only mathematics. आपको mathematics का equilibrium का concept है implementing in economics. So not only should your answer come out, but you have to check that the answer is implementable. Otherwise, what's the point of this? Okay. So this part is very important. You might solve for some equilibrium, but that equilibrium comes out to be something which is unfeasible. Then clearly that equilibrium is not acceptable, right? That means equilibrium doesn't exist in that cases. That would be the appropriate way to check it. Okay. The second important thing over here is that we need to ensure that the equilibrium should be stable in order to be meaningful. Okay. Does anybody remember the concept of stability? I have discussed this in our very first class that we had. So does anybody remember? Okay. Let me discuss it once more. Let's have a look at this graph that I have drawn. Negatively sloped demand, positively sloped supply, and we have an equilibrium point. Okay. Think of it in an economic way. What is equilibrium? Equilibrium is basically a point which you eventually want the market to achieve, right? As it is written in many of the micro textbooks, it is basically the point where the market clears. Correct? That is how it is defined as. So market clears का मतलब क्या है? कि whatever is the exact demand, that is the exact supply at that price P star. So that means what you eventually want by this concept of equilibrium is that if the price in the market is anything apart from P star, it should automatically come towards P star, right? That is what you want. Otherwise, P star will not be an equilibrium, stable equilibrium. So what you do in order to check stability is that you start with the off equilibrium price. Let's say your current market price is a price level P1, not P star. So at this P1, what is happening? Your demand is basically this much, and the producers are willing to supply this much. Correct? So this gap that is there in the market at this price E1 is basically excess supply. Correct? Supply is more than demand. And when there is excess supply, what happens? Too many sellers, less number of buyers. So the sellers will be bidding to put the price down to get their product sold. So when there is a situation of excess supply, price will have a force or a tendency to go down. Okay. So P1 will fall and will gradually reach P star. Take the other way around as well to ensure both. Suppose now you take a price level which is P2, which is below P1. So given this price level P2, your demand is this much, supply is this much and demand is this much. So this gap that is created in the market is basically excess demand. Correct? And when there is excess demand, what does it mean? Two less sellers, large number of buyers. So the buyers will be wanting to bid higher and higher prices, and this will put an upward pressure on price, and the price will be tending to rise. Okay, these are the market forces. Correct? So when the price is at an off equilibrium, what are the market forces giving you? In this situation, whether you are above or below P star, you have a tendency to converge to P star. So that makes the equilibrium stable. Is the idea clear with all of you?
Yeah.
Others can also confirm me with a yes or a no if this is making sense.
Yes, sir.
Okay. So if I just put it in two lines over here, I basically want a situation where stability means that the market forces are acting in such a way such that the convergence is at the equilibrium point. Okay, got it? This is the idea. Because if the equilibrium is not stable, that clearly means the market has no tendency to move towards that. So although you find the intersection, that intersection becomes meaningless. Okay. So three things to be taken note from here. The first thing is you need to solve for the equilibrium, the first step. Second thing is to ensure that it is feasible. P star and Q star should be positive. And the third thing is to ensure stability. Okay. These are the three things that we need to do. Now, graphically, you can do it. Otherwise, I will also show you one more method that can help you to do this.
Hello.
So, yes, anyone
Sir,
asking anything?
sir, I have a
Yes.
question that this stability actually we calculate from Walras method also. So if they are not mentioning anything, then as we assume that it is Marshallian method.
Shubhrato, like finding stability can be done by either ways, right? But both should give you the same, but both will give you the same result. So typically in exam, no one will mention you solve by this or solve by that. You're free to choose anything that you want. Okay, if you wish to draw a graph and find it, you can. If you just want to solve it using some numbers, that's also fine. Okay, no hard and fast rule implemented over there.
Okay.
Okay. Okay. So what is the idea? So the setup should be stable, and that should imply that the equilibrium is stable. So basically, yeah. All right. So now let me show you this idea. To check for stability, you can check it either ways, but one is more preferable. If you look at the prices which are below P star, if you're having a price level of P2, then the market forces are such that it will try to push the price level up. Correct? And as the price level is pushed up, the excess demand will gradually disappear. So stability implies that excess demand should fall as price increases. That means if I write it in the derivative terms, d of ed by dp should be negative. Correct? Is it making sense to all of you?
Yeah. Yeah.
Market forces imply that if there is excess demand, then this should happen. Otherwise, it will not be stable. So now let's check it for the system. For this system, you are simply given the demand curve to be QD is equals to alpha minus beta P, where alpha and beta are positive. Supply curve is basically QS, which is minus gamma plus delta P, where gamma and delta are positive. Excess demand is defined as demand minus supply. So which is alpha minus beta P minus gamma plus delta P. So that is alpha plus gamma minus of beta plus delta into P. Correct? So now what you will take? Derivative of the excess demand with respect to P. So that will simply give you minus of beta plus delta into P. And now the target is to check for stability of the equilibrium, right? So that means we want to check now. Therefore, d of ed by dp, we want to check at equilibrium. So what you will do? You will replace p by p star. So this is minus of beta plus delta into alpha plus gamma by beta plus delta. So this is minus of alpha plus gamma, which is negative. That means the equilibrium is stable. Is this idea clear with all of you? Is this making sense what we just did? It's just a two-step calculation that we have done. Although if you simply look at the first derivative, minus of beta plus delta into p, from there also you can conclude, but since specifically I only want to check for the equilibrium point, so you need to replace p by p star, and this is the result that you will get. Is this okay with all of you? Any questions?
So if we differentiate excess demand with respect to P, then it will give minus delta minus beta plus delta of P.
Oh, sorry, very sorry. Yeah. This won't be there. Yeah, sorry, my bad. So minus beta plus delta. So this is always negative. That means at equilibrium also this will be negative. So the equilibrium is stable. Yeah, very sorry for the calculation error. This is fine.
Yeah.
Is it correct now? Yeah. So
Yeah,
that
yeah.
means what? At every point for all price levels, the system is stable, whether you are at equilibrium or off equilibrium. That is what it means. But if I give you the other way around, you can see. What if I give you, let's say, another case? Like now the demand curve is this. If we just switch the equations, QD is equals to minus gamma plus delta P, and the supply curve is QS, which is equals to alpha minus beta P. Then in that case, what is happening? Graphically, we are just simply switching the signs, right? Negatively sloped supply and positively sloped demand. That is what is happening. So this is your demand, this is your supply. So the equilibrium value will remain the same, right? They won't change because the equations are typically the same. So in this case as well, your P star will be alpha plus gamma divided by beta plus delta, and your Q star will be alpha delta minus beta gamma divided by beta plus delta. But what about stability? Can anyone tell me? How can we check that?
Yes, I have the excess supply. Like
You can take excess
if
demand only. One will work. Just
okay, then
stick to
excess
one.
demand it will be greater than zero if we differentiate it with the
Yes,
respect to.
excess demand will be QD minus QS. So that is minus gamma plus delta P minus alpha minus beta P. So that is minus gamma minus alpha plus beta plus delta into P. So now if you do D of excess demand by dP, this will be simply beta plus delta, which is positive. So not stable. That means although you have found an equilibrium which is feasible, it is not stable. So that means it is not really useful in an economic sense. Okay. So although you have found the equilibrium, we actually reject it, so to say. It's not really useful for economic purposes. All right.
Yeah.
Okay. Now comes the next part of the story, that the equations that we are taking to represent the demand and supply are linear, right? Straight line equations. But this need not always be the case. That always you will have straight line linear demand and supply curves. You can represent, you can have non-linear equations as well. In that case, how will you do it? So let me put down two cases side by side for you. I think um, I'm not taking any specific equations. We are just drawing the graphs. Case 3. So this is P over here, Q over here, 0, P over here, Q over here, 0. Suppose, let's say that given the demand and the supply equations, the demand curve is something like this. And the supply curve is something like this. Okay. So if you simply solve it, you will get 2 points, right? As equilibrium, E1 and E2. But can you accept both these equilibriums? What do you all think? Are both the equilibriums accepted?
No, sir, because in the first E1 will be P star and Q star will be less than 0.
Only Q star will be less than 0, right?
Yes, I'm sorry. Yes, Q star will be less than 0.
Exactly. Exactly. So that means the first check is only unsatisfied. So this is unfeasible, right? That is the first thing that you can see, and hence directly reject. No need to check for the other one. But what about E2? E2 is feasible, right? Correct? E2 is feasible. What about stability? What does it look like? If you're looking at E2, the demand curve is negatively sloped, correct?
Yeah.
In the
Yeah.
neighborhood of E2, and the
Yeah.
supply curve is positively sloped. So if you use the same idea that we have used for straight line demand and supply curves, this will be
Yes.
stable, correct? So E1 is feasible as well as stable. So we will be accepting this equilibrium. Is the idea clear with everyone?
Yeah.
Okay. The first one simply unfeasible, so direct rejection. The second one is feasible and stable, so that's why we are accepting. Now let's take case number 3. Let me draw it and then you all can draw it. It will be a little difficult to illustrate it, but I'll try. Can all of you hear me?
Yes, sir.
Yes, yes.
Yeah, sorry. Let me just reshare the screen. Yes, so coming back to our discussion. So this is the case 3 that I have drawn. So what do you all think about this? Should we accept both, or what should be the case?
So both are feasible, but one is stable and one is not.
Which one is stable and which one is not?
E2 is stable.
E2 is stable. Correct. So the idea is that both are stable, both are feasible, so that check is okay. But if you look at E1, if you simply look at the neighborhood, okay, around E1, what is happening? The supply curve is negatively sloped, demand curve is positively sloped. So that makes it unstable. And if you do the same thing around E2, then the demand curve is negative, supply curve is positive. So that makes it stable. Unstable, so reject. And stable means accept. Okay. So although you might find multiple equilibriums, it might be possible that all of them are not stable, and hence you might have to reject it. Okay. Now, when I'm bringing in that idea that the demand and the supply curves can be non-linear equations as well, it can be taking different shapes, right? So it might not be possible for you every time to correctly plot the diagram and see what is happening. All right. So that is where, if you want to check the stability, the derivative criteria will come in handy. Okay. Let's take one example to understand this. Suppose I give you this question that the market demand is basically QD is equals to 4 minus P square, and the supply curve is equals to, let's say, let me keeping it simple, 4P minus 1. Okay. How are we going to find the equilibrium? Can anyone tell me what would be the first step?
Finding P star and Q star. P star.
By equating both.
Exactly. So at equilibrium, we need to equate both of them. QD is equals to QS. So that means 4 minus P square is equals to 4P minus 1. So if you take everything to the right, P square plus 4P minus 5, right? Or P square plus 4P minus 5 is equals to 0. How can we solve this? Can anyone tell me?
Minus 4, minus 1, minus 4. Like that.
Minus what are the answers?
I'm not. No, I'm not mentioning the answer. I'm just we can like
So it will be P square minus 4P minus P minus 5P
Sorry, what?
plus P minus 5 equal to 0. From there we can do,
Can you repeat one, Subrato? What?
so it will be like P square uh, plus 5P minus P minus 5 equal to 0.
Okay. So you're doing a middle term breakup, right? So this is a quadratic. Yes,
Yes,
perfect. So this is a quadratic equation. So it can be solved in two ways, either middle term or Shridharacharya. So this will be plus 5P minus 5 is equals to 0. So
answers are
P
P is
into
equal
P,
to 5 and minus 1.
ulta.
Delta.
P is equals to -5 or P equals to 1. So -5 will be rejected. So the ultimate answer is P star is equals to 1. Check it, Abhishek. Calculation
Yeah,
error हुआ होगा.
just one minus. I missed it.
हाँ. Okay. All of you getting this? So you will
Yeah,
simply reject -5 because it's unfeasible. Straightforward. No other things to be considered. So now having obtained P star, just replace it anywhere in the demand or the supply curve to get to Q star. So if I replace it in the demand curve, the optimal quantity will be 4 minus P star square. So 4 minus 1 square, which is 3. Correct?
yeah.
Therefore, the feasible equilibrium that we have got, the P star Q star values, P star is 1, Q star is 3. And now we want to check for stability. So for stability, what will you do? We will try to capture the, yes, we will try to write out the excess demand. Excess demand is basically quantity demanded minus quantity supplied. So the quantity demanded is 4 minus P square minus the quantity supplied is 4P minus 1. So this is basically 4 minus P square minus 4P plus 1. So that is 5 minus 4P minus P square. The next step is derivative of excess demand with respect to P. So that will give me minus 4 minus 2P. And you need to check for at the point of equilibrium. So that is minus 4 minus 2 P star. That is minus 4 minus 2, which is minus 6, which is negative. Hence, the equilibrium is stable. Okay, got it, everyone? Is the idea
Yeah.
absolutely clear? So when you have
Yes,
these kind of equations, just a simple derivative will prove to be more handy in comparison to if you're trying to plot it. Although I would request all of you to give the plot of these equations a try as well. Okay, demand curve actually, so you have got all the possibilities, right? All possible equilibrium values, stable, unstable, कौन stable है. So we have got all that information. So now, can you simply try to plot these equations, everyone? How would they look graphically? Okay, this I would keep as a homework. Draw the equations graphically. Okay,
One would be straight line and one would be curve.
कौन सा curve?
Demand. Like
अरे
it will
कैसा
be
curve? कैसा curve? Curve is a very vague statement, right?
parabola. Parabola.
किसने बोला?
quadratic, sir.
Quadratic is the equation, Shubhrata, not a curve.
Okay, sir.
Quadratic equation gives a parabolic curve.
Yes, sir. Yes.
But which kind of parabola again? Up, down, left, right, which one? Okay, all these things I want you to just try once and then maybe I can discuss it. Okay, this will help you in your math part as well. All right. So I hope the idea is clear. Yes. Yes, Ayush, you have raised your hand.
नहीं सर वो पीडीएफ के लिए बोल रहा था आज भी नहीं आया अभी तक कल वाला भी
Same problem.
ऐसा कोई डाउट नहीं
नहीं आया.
है ना मैथ वाला आया ना कल वाला आया
Yes, yes.
Maths में third. Okay, ठीक है. I'll ask once.
मतलब इस वीक में जितने भी क्लासेस हुए हैं एक का भी पीडीएफ नहीं आया
कौन सा पीडीएफ?
Last 3 classes.
Last.
तो जो अभी क्लास
Okay.
चल रहे हैं उसका
Last 3. ठीक है. I'll pinpoint that out. Okay, so ये वाला concept clear है सबको? कि whenever we are actually trying to find out equilibrium, there are two add-on things that we need to check. One is the feasibility and another one is the stability. And कैसे निकालना है? I hope it has made sense to everyone. Okay. So let me put one question as homework. It should be easy for all of you, but just for practice, you all can check this out. Suppose the demand curve is this. QD is equals to 8 minus B square. And the supply curve is QS is equals to B square minus 2. Okay. So the question remains the same. You want to find the equilibriums, check which one is feasible, and conclude about feasibility. Sorry, stability. Okay. Just try this and we'll pick it up from here in the next class. So